Welcome to our Lincoln Electric TKY offshore joint time trial. This time trial is for offshore jacket structures. Now, the offshore jacket structures in particular are the ones that are the subsea foundation for offshore wind towers. Now, the reason for the video today is to show you the substantial time difference between welding these TKY joints with the traditional single arc flux core gas shielded wires. What we have here today is single arc flux core set up on the left hand side of this power wave unit here, and we are comparing the traditional process with the Lincoln Electric patent process of hyperfield twin flux core wire. This in particular is an air-cooled torch for the flux core wire. We have the two spools set up on this side of the PF84 dual and the power wave system. Now, behind me here you'll see three very distinct joints that we're doing the time trial on. These two are welded in the horizontal position. We are welding 50% of each joint, half of the joint, with traditional single arc flux core wire. The other side of the two joints will be welding with the hyperfield twin flux core process. Now, the reason we have the two joints is very specifically we have two distinct gases. We have CO2 100% and we have mixed 80-20 shielding gas. Now, moving to the third joint, we are doing the third joint in the vertical up progression. This joint, again, 50% will be done with single arc traditional 1.2 flux core. The second side, or the other half, will be done with the hyperfield process twin 1.2. And in this particular joint, we're using the 80-20 mixed argon CO2 shielding gas. As you can see, we are now single arc flux core wire process 1.2 millimeter. This is the process that you would normally use in your fabrication shop. And as the weld finishes, you will see that the arc time is 53 minutes. As you can see now, we are welding the other side of joint 1 with the hyperfield flux core process. As we come to the end of the weld, you will see it's 30 minutes of arc time. That's an overall reduction of 42% arc time. That's quite significant when welding a structure of this size. We have a video now showing the operational characteristics of single arc and hyperfill. We have a slight drag angle, which is typical for this traditional process, and typical electrical stick out, which is used all around the world. And as you can see, they are exactly the same. There is no retraining required. Now we have just completed weld number 2, and that is using 100% CO2 gas. Again, 50% of the weld was welded with single arc flux core wire traditionally, with an arc time of 50.4 minutes. The second half of the joint was welded with the hyperfield process, again 100% CO2 with an arc time of 32.8 minutes. An overall reduction in arc time of 35%. Again, in a structure this large, that is very significant. As you can see, we have now just completed weld number 3 in the vertical up progression. On one side, we welded half with the traditional 1.2 flux core with an arc time of 66 minutes. On the other side, we welded with hyperfield flux core 1.2 with an arc time of 49 minutes. An overall arc time reduction of 25%. Again, very significant in a structure this size in that vertical up position. As you can see from this video now, we are showing you the comparison between single arc and hyperfill, with particular focus on the arc characteristics and how you weld as per an operator with drag angles, etc. And as you can see by the video, they are exactly the same, regardless if it's single arc or if it's hyperfill. Now we're going to show you a video of the actual arc itself. We've spent a lot of time and research making sure that we get the twin arc to be identical to the single arc. software waveform control combined with the mechanics of the tip allow us to have an arc that is as flexible and is as focused as single arc flux core. Now you've seen the 3 welds completed and understand the significant time reduction between single arc flux core and the hyperfill patent process by Lincoln Electric. I just want to go through the equipment because every site has different environments, has different applications. So when you look at this section here, we've only really been using the PowerWave 500 itself and the Y-Feeder PF84 Dual because we've been using air-cooled flux core. But this is more of a shop system or package. If you're thinking about on site, getting outside and you need some flexibility, the PowerFeed 25M suitcase feeder is the one where you need that flexibility and that portability. You need to go up to certain heights and you can quick disconnect from behind. So this is your typical on-site flexible feeder, which will have the flux core, twin spools inside and allow you that more flexibility when you go outside.